Please welcome to our channel of Sciences and Mathematics. Today we are going to look at a different concept in acids, bases and salts, and that is the strength of acids and bases. Now we find that in some of the chemical reactions that we may encounter in our discussions and studies are going to maybe entail a strong acid or a weak base. Or maybe if we desire to make a particular compound, we are going to find that we require a certain degree of strength of an acid or a base. So this is going to come into play when we find or maybe try to find out a way in which we can be able to describe whether a substance that is acidic or basic is strong or weak. So this basically is what our topic of discussion for today entails. So thank you and welcome. So our topic of discussion for today, as I've said, is the strength of acids and bases. And we're going to see that from our definition, from our general definition, Arrhenius and Bronsted definition of acids and bases, we talked about the concept of a degree of dissociation of acids in water. Now, an acid can be referred to as a strong acid when we describe its degree of dissociation, of course, in water, as we said, to produce the hydrogen ions. Now, for instance, if we're going to have some of the examples of the acids that we can generally use. So in this case, maybe if I say an acid is strong, we're going to compare HCl, nitric acid, and perhaps sulfuric acid, and try to see how we can be able to represent these specific acids in aqueous solution, or maybe when they dissociate in water. So we're going to have this one represented as H plus Cl. This is the first one, 2, 3. So for the second one, we are going to have nitrogen nitric acid. So this is H positive plus that is N3 negative. And the last one we're going to have this I can mention there, states aqueous. And then the last one we're going to have for sulfuric acid. Now this is going to have this one. This is aqueous. In some cases, we're going to see this one, the level of concentration when it's maybe high, we're going to refer to it as a liquid. I'm going to give the reason for that. Now, in this case, this dissociation equation for the first, second, and third acids that I've mentioned. Now, the strength of an acid can be described as the degree of dissociation into ions which dissolve in water, as I've said. Now, if we try to look at these specific acids for the protons, the sulfuric acid has donated 2 protons by dissociation, but when we say about the degree of dissociation, we are trying to look at the number of hydrogen ions which are yielded. Now, for strong acids, they yield more ions, which are proton ions in water, whereas the weak acids yield or maybe slightly or partially dissociate in aqueous solutions to yield very few hydrogen ions. Now, in this case, we can have a class of strong acids and weak acids. The one that I've mentioned, they have a tendency of dissociating with a higher degree in aqueous solutions to form maybe hydrogen ions, which are more as compared to other acids. Now, we can give an example of a weak acid, like the ethanoic acid. Ethanoic acid that we have mentioned under the study of our nomenclature of carboxylic acids in one of our videos of organic compounds. So this is one of the weak acids, and we're going to see that this ethanoic acid is going to dissociate in of course water to form the 2 specific ions. This is negative. So in this case, this reaction is reversible, so we can be able to represent this one using those specific arrows. So this is one of the examples of a weak acid, and still we can give another one, which is a carbonic acid, which of course tells also the dissociation of now in this case, this one forms an intermediary compound just wanted to write a general equation for that, but it's good for us to just illustrate how that specific process of dissociation occurs, especially for that weak acid of a carbonic acid. So basically this one dissociates, this is a carbonic acid, this is reversible, so it dissociates to form hydrogen ions plus this intermediate species. And of course the final product for this dissociation is going to be plus the carbonate. So this part forms part of the weak acids, as we say, that they slightly or partially dissociate in solution forms in order to form those specific constituent ions. So basically, in that also sense, we can be able to define a strong base as the one that has a higher degree of dissociation to form the hydroxide ions when dissolved in water, whereby for strong bases, they undergo complete dissociation in water, whereas for weak, just like acids for weak bases, they undergo slight or partial dissociation in water to form the hydroxide. This is dissociation to form the hydroxide ions that we have mentioned. For instance, we can be able to give examples of strong bases, like the one that we have mentioned in our definition for acids and bases, like the potassium and sodium hydroxide. So for the potassium hydroxide, this is going to form potassium plus the hydroxide ions. In that respect also, we are going to have potassium that is going to form those specific ions. So these are some of the strong bases that we can be able to give an example. And basically for salts, as we said, the salts are we talked about the concept of neutralization. And we're going to see that in order for us to measure the strength of an acid or a base, we're going to use substances that are referred to as indicators, which are substances that have different colors in acids and alkaline solutions. So basically, we're going to say that we have different categories of indicators that we can use to measure the different degree of dissociation, which we have referred to acids for hydrogen ions and the bases for hydroxide ions. Now, we have what we call a universal indicator that we can be able to use to measure the strength of acids and bases, that basically shows a series of color changes in acidic and alkaline solution, as I've mentioned. And these indicators have a range of maybe gauges which are used in order to indicate the strength of acids, that basically entail the colors that I've mentioned, or maybe a range of numbers. I'm going to give an example on the board. So this is that's a range. So this is a pH range, and this is a strong acid, and therefore just going to complete this. Now, if we try to look at this range of colors which are being displayed are going to be indicated on a concept that we can use maybe generally like on a number line, whereby we've got 7 in the middle, and this is starting 1 to 14. So when there's a color distribution of which indicates a specific color in this specific chart that we're going to have for strong acids, weak acids, strong bases, weak bases, and there's some substances which we're going to refer to as neutral. So for strong acids, they have a pH range that runs from 1 to 3.5 along this scale that we have indicated. So towards this direction, this is an increase in acidity, and this is an increase in basicity. So in this case, we're going to see that the substances that have got a range that goes towards that direction, they are more basic, and substances that are ranging from number 7. So this middle term or middle number that we are referring to this being indicated by that scale on an indicator will show substances which refer to as neutral. So at number 7 we have neutral. So for strong acids, just going to adjust this one. This is a pH range. So we're going to have from 1 to 3.5. These are strong acids. And then from 3.5 to 6.5, these are weak acids. So this one is in reference to this range of numbers on this pH scale. So for strong bases, they are going to be from number 10.5 to 14. So along this scale, along that scale, from that one range is going to be. Now for weak bases, it's going to be 7.5 to 10.5. So this is how they vary. So in any case, if a substance displays when it has interacted with the indicator and it indicates a color that is bearing a specific range, then we can be able to mention whether the substance is basic or acidic. Now we're going to see different colors or different parts of or maybe different categories of indicators that we can use. Some of them which are easily found and some of them which we can be able to find in the laboratory, like the litmus paper, phenolphthalein, etc. So in this case, this is how we are going to look at the concept of strength of acids and bases going forward, and trying to see on what scale it ranges in the, of course, the universal indicator scale that I've drawn on the board. So for the specific concept of strength of acids and bases, I hope that we have that one has assisted us understand on how we can be able to refer to a substance as a strong acid or a base. So that is it for today. Thank you. Bye. God bless.